My name is Nick Redfern. I work for a firm called Rouse. We are a supplier of intellectual property services to the UK government for this FSIP project. And this training program was devised with IPTC to focus on IP commercialization for public sector institutions. We're going to talk about three main things today. One is technology transfer offices, the other is licensing, and the last is spin-outs. So we'll go into a lot more detail about those shortly. What I would like to do first is to provide a little bit of an introduction and some context, and we'll start with these slides for the next 25 minutes. So what is IP commercialization? Well, there are lots of definitions. I like this definition because it was created in Southeast Asia and is used in an ASEAN handbook, a book which the link to which is in these slides, which we can provide to you. And this definition simply says that it's the process to bring intellectual property rights to market for them to be exploited for business profits and growth. The point about that is there's no point just registering IP and doing nothing with it. And that will resonate, I'm sure, with many of you in public institutions involved in research and development, because that is one of your major challenges. All of the research and development going on, what do we do with it? How do we turn this into something useful? A slightly more nuanced or different diagram here and definition here, converting knowledge to money. You take knowledge, you take ideas and skills and some other things, you mix them in the IP commercialization machine, and out comes money. But there's more to it than that, because you need to validate that these ideas, this research and development, has some commercial market potential. You need to convert them to intellectual property, so they're backed up by some legal assets. Then you put them into deals and contracts, through contracts, and then you get the money out. Now, of course, we know that public money pays for R&D, so it's very important that we understand all the issues around how we can own and use that IP when it's been paid for by public money. Governments are the ones that aim to develop the economy. Public research helps a country develop various different goals, often via a research and development roadmap. Research and development needs to be targeted in order to be useful. Quite often you find that the market is very inefficient at focusing research and development. There might be no private research in one place. And we know that public research can motivate private research. R&D can have a social impact. It can help the government achieve certain specific goals like defense or education or health, or it can create income simply through commercial products. What this means is universities have a more advanced role in the modern economy. They have goals to do much more than just educate young people, but to create much wider research, knowledge sharing aspects. Governments are often weak at commercialization, and so the private sector partnership in that function is something very important, and we'll see that coming over and over. We talk a lot about processes for commercialization as well. And when we talk about TTOs, you'll hear quite a lot about the processes, many of which are quite well established all over the world. That is how you take ideas to the market, by converting them to intellectual property. This slide shows some public data on public versus private R&D. On average in the world, a third of a country's R&D is public and 2/3 private. It's actually less in developing markets. There's more public research and less private research. But what we find is public sector research can drive a growth in private sector research. And that again leads to this point about partnerships between universities and the private sector. So I like to use examples of my old university, so this will keep reappearing. It's called the University of Exeter in the UK. These are some of the tools that enable us to bridge the gap between universities and the market. IP policies, technology transfer offices, partnerships with public and private institutions, consulting by universities. We're not really going to talk very much about that, but some universities do a lot of consulting work to the private sector, certainly in the UK. Licensing, which we're going to talk about, and of course, spin-out companies, which we will talk about. The UK's roadmap for its national R&D, I've put a link to it in this slide, and it shows the amount of money that the UK aims to spend. It also sets out what the research goals are in the UK. Targeted research, and there's a whole series of different areas the UK specifically wants to target. One, for example, is cybersecurity. That helps universities focus on things that are within the national goals, and therefore raise money for funding research as well. The UK also seeks to develop more talent in academia to do research and development, to widen research through the regions of the UK, not just in perhaps the wealthier areas. And the last one, the UK aims to support research that helps meet the climate crisis. Another thing that government can do, apart from public sector research and driving private sector research, it can use procurement to procure things. Governments have to buy things. And quite often in the UK and in many other countries, they buy things that come from public or publicly funded research in preference to something from the commercial market. It's a way of supporting research commercialization. I'm sure you'll be very familiar with the concept of who owns the research. It is always a challenge in every country to identify who owns it and why. Usually the basic principle is public government funding of research means the government owns the IP. Now that is not a good solution in every case. So sometimes, well, then you then have to ask, who is the government as well? Is it the National Research Institute or the national organization that paid for it? Is it the individual local research institution where the research happened? Is it the academics or individual researchers? Who else? And the laws have to address this in each country. If you don't have a bit of clarity around that, it's very hard to identify who owns the research and what can be done with it commercially. So this is something that Vietnam must understand and look at, which is, do the laws match what the R&D institutions need to deliver? Now, I understand that there are some principles around this, but most public research is publicly owned, and that's something which might need further development at the legal level. In the UK, how does it work? Well, here's a bit of history. We used to have a single national research body, and it owned everything. This is back in the 1970s and previously, but that was not very effective. So this was converted into a new organization. All of the historic research was packaged up into one company called BTG. That company was then spun off and listed on the stock market. All the ownership, all the shares were bought by public people, but the sale of those shares, all the profits and proceeds went to the government. So the government basically drew a line and started again. And from the 1980s onwards, individual universities could then own the research, the universities that did the research, so not an umbrella organization, the actual entities, kind of made more of a let's say, a free market approach to how the universities could operate. But what that means is the universities could decide their own policies on how to develop and commercialize research. So that's maybe a little bit interesting how the UK had started with complete public ownership, worked out a solution for that, and then created a new system to have the educational institutes, which are public organizations, but they individually own it. So it's still publicly owned, but they have complete freedom to decide what to do with it. Sometimes that means it's not always clear who owns it. Does the university have complete freedom to use it, or do they have to get the researcher involved? You usually have to talk to them to find out within each university what their policy and structure is. This is a case study. It shows a couple of things. Firstly, there is a network of universities in the UK focused on robotics and artificial intelligence in the nuclear industry. So it consists of maybe 10 universities, all focused on the same area of research or similar area of research. And sometimes they work together, sometimes they work separately. But we'll come back to this network approach. It's very powerful in supporting IP commercialization. The more networks each university has, the more it can achieve. And this is one example. The University of Manchester, through this network, got access to a special grant fund, which had been created for this technology area. That meant they could do the research they wanted to do. They created the Karma robot. This robot maps nuclear radiation. There was a very good reason the UK government wanted to spend this money. And that's because they had to decommission a nuclear power plant. And someone had to deal with where all the radiation was. So this project enabled this robot to go and do that, which validated that it had a purpose, market function, and that now means that the robot can be commercialized for other commercial uses. I mentioned networks. It often starts with research collaboration. And most research today is done in partnerships, an awful lot anyway. Possibly there's basic research with applied research. Possibly there's public sector and private sector collaborations. It's often said that collective work is more effective. Partnerships can be local within the area you're in. It can be national. It can be international. And it can be public or it can be private. So there's quite a lot of options. Another aspect, apart from the research aspect, is funding. And we see this a lot in the UK. The UK does not have a single funding authority. In fact, most countries do not. There are often multiple, quite sometimes confusing, funding authorities. But it means projects can get co-funded, joint funded, public-private partnerships. There may be grants, there may be all kinds of different ways to fund research, and the steps beyond research. When we start talking about spin-out companies, you're going to see that some of the financing needs to be for things other than research. So it's critical that we develop partnerships for every research institute with other institutions, locally and nationally and internationally, with the public sector as well as the private sector, but also with funding partners and perhaps with other businesses as well. So this case study shows a couple of things. First of all, defense spending is something that governments often keep as a public focused research. And in the UK, 85% of it is public funded and some of it's secret. It might still be done in universities, but under strict secrecy rules. But there is another 15% which is outsourced into the public sector and the private sector as well. So an example here with Imperial College in London is a partnership with Imperial College to reach out to SMEs that they know who have got ideas that need development support. And once they're put through a process that is run by Imperial College, which has got a very successful IP commercialization program, and they can find ideas in the commercial business market that can be taken into the military use. Another example, again, my old university, the UK Defence Department has a partnership with Exeter University focused on virtual reality and augmented reality. And this is used, as you can see in that picture, for military training, simulation, and modeling. And that's an example of the government supporting, with the university, public research, which then goes back, of course, into defence use. I'm going to stop now and start talking about something much more technical. Particularly the UK, where individual institutions have their own IP ownership and policies and structures. Each university has to have an IP policy, and that's the policy for the whole institution. And it will govern a whole range of different things. I've given you several links on this slide to the UK government's tools, to Cambridge University's policy guidance, and to the WIPO tools. But by looking at all of those, you could very easily develop your own policy or improve your own policy if you needed to. Some of the things that this covers: ownership and rights to use IP, of course, because we're talking about IP commercialization, but also the procedures to identify, evaluate ideas, and then decide on protection and management of IP. Usually the TTO will take on a lot of those, but the researchers might have responsibility to do some preliminary searching, for example, on patents. You also need cooperation procedures for third parties, whether they are research partners from the public or private sector, international or local, with co-funding or other organizations that support you in some other way. Guidelines for sharing profits, especially with co-funded research or co-developed research. Very important that we respect third-party intellectual property rights. So the entire university has to have a policy on respecting third-party ownership of IP, so we don't copy anything by mistake. What publication or dissemination of research is possible? We mustn't publish research and damage the patentability of the research. Who's got the obligations to do what? And lastly, protection of national and public interests. So this is just a broad set of headings, but you can see that there's quite a lot to cover in a policy, and the links there go into a lot more detail. Just to delve into a bit more detail on one area, how do you work out who has contributed what? This, I know, is covered in principles in Vietnam's laws. Basically, there are external influences on the research and development that takes place. Your IP policy might be an important, probably the most important factor, but where you partner on research, there will be research collaboration contracts. They should be in line with your policy. They should be a model collaboration agreement, actually. Use of third-party materials and other contracts for parts of the development, material transfer agreements. There are lots of different types of commercial agreement that a university might need to use. Again, there are standard topics, standard templates that you can find for all of these, especially at WIPO. Co-funding agreements, all of these can affect how you own IP. So I'd encourage you to go and look at those links in the previous slide to understand a lot of this. Many contracts are involved in IP commercialization, not just the creation of the IP. So one of the key skills of TTO officers is looking at and understanding contracts. But very often you'll need to work with outside advisors. I'm sure you're all quite familiar with different types of IP. Patents are often the most common with university research, but they are very rarely the only ones now. Trademarks are not so common at the university level, but with spin-out companies, they need to be created. But designs for product configuration could be important. Trade secrets are often a very valuable component of research. Most of your research data will comprise trade secrets. Copyright is often very important today because of the software that accompanies research. So I'm sure you're probably quite familiar with this. It's usually the case that a TTO or a university commercialization office will need to work with outside advisors and they will need to use searching tools and various other IP tools to develop their IP capabilities. A bit more detail on IP. This just simply gives you some ideas about how a TTO is dealing with third parties. Obviously you've got to register the IP at the beginning. That requires budgets, so you'll need to have processes to identify the IP, to work with the researcher to crystallize it, and then file it. There might be multiple patents filed before the commercialization phase starts. Remember unregistered rights like trade secrets and copyright for software. They will all exist. They often get overlooked. When you want to commercialize the IP, if you don't have the trade secrets and copyright wrapped up as well, investors will be much less interested. I mentioned tools. Okay, patent searching, patent evaluation, patent mapping. These are the kinds of tools that are normally available. I don't know whether some of you have access to such tools through IP Vietnam or through any other organizations. There are many commercial tools on the market as well that can be obtained. You'll need to create an efficient network of IP advice. You might need to have a specialist patent attorney involved. You want to centralize the IP function so you're not duplicating as well. Otherwise, you'll just waste money. And you will need contract support. That might be external lawyers, or it might be using templates, and so on. A lot of this will require training. And that training can come from many sources. People like us, projects like ours. But I don't know if it exists in Vietnam. In many countries, TTOs and universities have their own national association. And they will run events and training and various different ways to educate the members of that organization, which are usually the TTO offices. And there are many international ones as well that work worldwide. I want to show one case study here, which is something which is interesting because its goal was not commercialization. The UK, many years ago, decades ago, took the decision that it wanted to create a long-term scientific advantage in molecular biology. And so in order to do that, they founded a new institution at Cambridge University and very specifically gave it a long-term budget. So there was no demand to commercialize everything in the short term. That meant they could go into some very deep and very complex research, which would be otherwise too difficult for them to get into because it would take so long to commercialize it. Those budgets were 5 years long, so they didn't have to justify anything for another 5 years. What it meant was they could develop expertise in DNA sequencing, in protein structures, in monoclonal antibodies, many different biological and molecular areas, leading to some very big international successes, such as the first synthesization of the E. coli genome, which is the African virus. I'm sure you're all familiar. 12 Nobel Nobel Science Prizes have been awarded to the laboratory's scientists over many, many years. Incidentally, this led to a hugely successful technology transfer office. But that wasn't the main advantage at the beginning. That wasn't what they were demanded to do to justify their funding. But it was a good consequence. So I wanted to show that because it's quite important to see that the distance between research and commercialization can vary depending on the goals.